All right. Good morning, everybody. This is I don't know what day it is, May 18th, 2021, CAPN office hours. We got a couple things on the agenda, and I think I want to spend as much time as we possibly can doing some backlog and milestone management if we can at the end of this. If there isn't other topics, if there is, please make sure you add them to the agenda so we can cover those things. At some point as well, Vince will join and we'll talk about KCP and not the KCP that we talked about last week, but specifically Cappy's KCP. I think that'll be an interesting conversation. Charles and I have been chatting a little bit about that, and I've had some one-off conversations with Vince, and I kind of wanted to see if we can solidify a direction that we could do a proof of concept there, just to have another piece in place within CAPN, just in case we ever want to switch towards using more KubeADM based workflows. The first PSA as well, we're all the same people that we always are, so there's no new introductions. The first PSA that I wanted to actually jump into is, let me share my screen. We did not actually close our milestone, so it's basically just looking like it's been open for a hot minute, and I want to make sure that everybody's clear with me going and closing this. Come on, Zoom handles, go away. Oh, there we go. So under milestones, let me go find that. Milestones. When we were originally doing the planning for this stuff, we basically created that 1.0. We've been 100% complete for the last week and a half or so. I wanted to make sure before I close this that everybody feels comfortable with that and feels like they can at least use it. Charles, I know you did that. The docs today for actually being able to provision that might have made sense to actually have that in this 1.0, but at least we can close it outside of it if you want.
Yeah, I think we can close it outside of it. I will make it. I will revise it based on your comments today.
Yeah. Cool. Yeah. So then I guess we can put that in. If it isn't already in here, it is. Okay. So that can be in the 1.x release. So we'll close that out with that. Cool. Does anybody have any concerns about me actually closing this so that it, looks like we aren't 18 days past due?
Yeah, I think we can close. So do we have a plan to have a release soon? Maybe this week or?
Let's put that on let's file an issue for that. Let's see if we can do that. That'd be I think that's a good idea. Because I think we are getting to that point where we would be able to create the cluster cuddle integration with this so that we could at least deploy those control planes. But let's file an issue and see if we can get to it. See if we can have somebody work on that. Because I haven't actually done any of the release proud jobs, and those will take a little bit of time just to make sure that everything's all set up properly. So we need to spend some time on it.
Yeah, but I think we don't have to depend on the class cuddle to be working for first, right? For the first
True. We can definitely do a release without it. It's more that we need to set up all the proud jobs to actually do the releases, because that's where all of that G-Cloud stuff actually gets initialized and it'll get pushed over there. I don't know what the timeline is on doing those kinds of things. Like, do we need to get a project set up? Who do we have to work with from SIG Cluster Lifecycle to make sure? Because those are all going to be owned by that G-Cloud account that all of the CAPI providers actually get rolled up under. So there's like there's just some management stuff that we need to work through.
Okay, so because this is SIG, because I haven't made a release for SIG project, so for other project release seems to be simple. Just click GitHub, make a release, and that's it. So because of this is a SIG repo, so we have more steps need to follow. So I'm just curious.
I think so. It's more uncharted territory for me. If when Vince joins on, we can ask a couple questions about that, so we can fill out the issue fully. Scott, you might know as well. I don't know if you've ever worked with any of the releases on any of the providers.
I haven't worked on the releases, so not sure.
Okay. Yeah, so we'll file an issue and we'll get that done. We potentially could get it done this week. I don't know how much work it is I guess what I'm getting at.
Yeah, I'm also interested. Yeah, I don't think it will be way too complicated, but yeah, I think I talked with you before. We probably can do kind of two different releases for KPN and
virtual cluster versus.
Yeah.
Cool. All right. Well, then I'm going to close this just so we're at least done with one milestone. And then I want to go back over to here and see where we're at. Okay, so cool. So we're at least done with that. Well, at the end of this, we'll jump into doing issue management, and we'll get some things filed so that we can fill out that 1.x release, and we can put that together and actually set a timeline for when we want to achieve that. The other thing that I wanted to do, and I'm kind of following the instructions here. There's a little bit more process about this, but I wanted to bring this up. So I filed this issue just because, oops, apparently I'm copying and pasting things. I'll just go over to the issue. So if you're not familiar with this, there's a working group naming working group that got created, and we're in the process of switching a lot of the repositories over from using the master name within branches and switching that to being main. A couple of the CAPI providers, specifically AWS, I saw has already gone through this process, but there's a handful of instructions here. One of the gates that we have to do to be able to close this is to talk about it and make sure that everybody knows this will happen. And so I wanted to talk about this last week, but we just didn't get to it. But in essence, this week, I'm going to spend a little bit of time and push up a new tracking branch for us. So we'll be tracking against main instead of master for all of these things. It shouldn't change anything because we have, because I already set up the proud jobs that we have in place to work off of both master or main. So it should just flip relatively simply. And this is just kind of to align all the repositories with the proper path. And so basically need to bring it up with everybody on this call, make sure it's been announced. And then I'm going to write a quick little email to send out to the SIG Cluster Lifecycle mailing list, if I recall correctly. Basically, there's like this send comms that you have to do a couple times that tell folks that might have seen the project that this change is happening. So I'm just being pedantic about the steps that need to be done for this. And if you're interested, you can follow either of those links.
Are we going to remove the master project? Are we going to remove the master branch?
Yeah, so basically master branch will go away. We'll just have main, and we'll track off main. So anytime you have this project locally, you're going to need to reset up your tracking branch to be main, and then that's it. It's just replacing the name.
Yeah. If you remove the old one, I think it should be okay because you will realize that the branch name has been changed. So my only worry is you leave it and create a new one. So.
Yeah, I think that's one of the steps in here. So we need to rename the default branch to main, set the remote tracking to head, or remote head to track main, and then we're gonna have to go clean up where I have master still in the proud jobs, and then I don't think we have anything from them. Oh no, we do actually use the milestone applier, so I do need to change that proud job as well after. So this week that'll happen, and I'll send out messages in both the mailing list because that's part of the docs for actually doing the branch rename. And then I'll also send out a note in the CapN Slack channel so that we can all know when to switch our tracking branches.
Is this going to happen for all the SIG project?
Over time it is. And I believe it's actually eventually going to happen on Kubernetes too. I just don't know what the timeline is. Like there's a whole doc that the working group naming, or the naming working group wrote up for how to go about this and how to reason about it. And only a few projects so far have done it, but the idea is that everybody should be centering around main.
Yeah, well, what is the main reason? Can you explain in 2 sentences? So
inclusive naming.
Okay.
Yeah. So we got to follow the proper naming for all things so that we can be inclusive to everybody, which I think we should. I think it's a good idea to get behind. And if we can get in front of it, then we can make sure that we have, if we find anything or run into any issues while doing this, we can push a lot of those changes back and help that group out from a community side of things. Okay. So cool. All right. So that'll go out this week. I'll send out a note when that actually happens so that we all know that we can change our tracking branches. Vince, just FYI, one of the things we're going to do this week is change tracking to main since you just joined.
That's awesome.
Cool. All right. And now that Vince is here, Charles, and we wanted to basically talk with you. I'm going to stop sharing my screen so I can see everybody's faces. So before we jump into all the backlog grooming, Vince, you and I have chatted about this, and we chatted in Slack just right before this, just to give you the primer. But in essence, Charles and I have had some one-off conversations similar to the ones that you and I have had about where we are with the project. So to give you a quick update, we basically just closed out the V0.1 milestone. We didn't actually make a release because we haven't set up any of the release proud jobs. So I'll talk to you about that a little bit later. But we basically have it so that you can create control planes. We have a video from 2 weeks ago that actually shows the control planes getting brought up as well. I sent you the link to the current docs for how to set up CapN. That being said, as you and I have had chats about this, we have a control plane provider that we implemented ourselves and now have to maintain that whole code base, which is nice because we have control over it and we can figure out what we want to do in the long term and make sure that it fits everything to make nested control planes work. But you all have already written a very, very thorough control plane provider that's based on kubeadm. And so now we kind of have two different implementations within this structure where if somebody were to be a heavy user, say for instance, Scott, because he does this already, works with AWS and works with Google and works with a bunch of other providers, comes over to CapN, it's a completely different implementation and the API is different. And so we wanted to explore a little bit more from a proof of concept perspective, what it would be like if we could utilize KCP to actually do the maybe not provisioning or the setup in essence. So I think the things that you and I have chatted about for how this would actually work is, or the things that KCP actually needs to work are it needs to actually have machines, which is something we don't currently have within the nested control plane. Correct?
Yeah.
Okay.
Okay. Go ahead.
No, go ahead. Go ahead. Was there going to be more?
So KCP takes a infrastructure ref that you could use. So you could just have like some sort of shim there to then, yeah, but that's going to be tricky. So what were you thinking? Like how would you want to do this?
Well, I don't know if it's the best idea, but the way that you and I have chatted about it before is like, if we were to take what we have from the nested cluster side of things and we implemented nested machines, and nested machines didn't actually represent physical machines, but we kind of mocked that, we could potentially utilize what KCP is doing. So it would be implementing a little bit more on the infrastructure provider. We just kind of shelved the nested control plane code base for right now, if we were to go down this path. And it would be following the same model as what we have with the Docker provider, in essence, where the Docker provider kind of doesn't actually, and correct me if I'm wrong, but the Docker provider that's in tree doesn't really use KCP's any of the cloud init or any of those pieces. It just tries to model itself based on whatever the kubeadm config is that gets generated for that control plane. Correct?
Yeah, it will. It won't use that directly, but it will use that information to then create those machines.
And so I think in essence, that's kind of the path that I think could potentially work, doing a very similar thing. But in our machine provider, we do some hacky things to basically generate pod manifest from that. Some questions in there is like, is there ways that we can get, which I have never found, and I don't think I've dug deep enough into this, is like, is there ways that we could find, sorry, all my desk just shook. Is there ways that we could get the static pod templates that come out of kubeadm that are typically put on the actual disk for a physical machine? And can we get that pod template and use that as the pod spec within a deployment or a stateful set to generate these things without having to actually have a physical machine that runs the imperative or like the kubeadm commands on them? Because I want to leverage as much as we can out of kubeadm to make this thing a little bit more stable in essence.
Yeah, so I don't think you can do that specifically, mostly because like you would need to run kubeadm, and we don't vendor kubeadm because it's in Kubernetes, which is a dependency issue because we want to support multiple versions of it. Now that said, like the kubeadm config, if you use the KCP, and so it means like you will use like a KPK as a bootstrap provider, you could use that kubeadm config to then generate your pod as you best wish, pretty much. Like, so you need to convert the kubeadm config then in the static pod manifest. I'm sure that, so there is like another whole set of issues that like are trying to make kubeadm more accessible as a library, but because of the tight dependency with Kubernetes, like it's not today. So we could probably like reuse, as in copy some of that code for now, and then use this as like a forcing function as well to add to the use case. Like, hey, maybe we want to like have a staging repo or something like that.
That's an interesting idea. So the idea there would be basically start to use this, copy some of that code out, start to use this as a, hey, we're trying to leverage these packages. Can we start to talk about what it would be like to make it so that more of kubeadm is not just vendored in Kubernetes itself, and we could actually, okay. And so from a CAPI side of things, we don't vendor any of kubeadm. We basically have copied over a lot of anything that we're actually working with.
Mm-hmm.
Okay. All right, that makes sense. And so from a machine provider, just to fully draw out the story and make sure that I'm on the same page as well, Charles, if you have any questions, make sure you bring those up. From a Bootstrap provider side of things, that's going to go and write all of the Cloud init scripts that are then going to be instrumented by a machine controller, which is what's going to actually drop it into wherever it needs to actually run the script. And so if we were to take that same sort of model, we would just kind of omit the actual Cloud init scripts, take the kubeadm config from KCP and try to generate manifests in that control plane provider. Okay. All right. And okay, so we'd be able to generate the manifest. So you probably take a lot of the code that we already have and just make it so that it was a little bit more customizable in essence with the manifest that we've already written, and then just do the interpolation of the variables that get passed into it.
Agree.
Now,
besides of the code, leveraging the same code structure, so what are the other benefits? Does kubeadm handle all the upgrade story and all the upgrade workflow that we can leverage? Because in the first place, I was thinking, functionality wise, I mean, unless we can leverage a lot of workflow that we are missing, if it's just trying to leverage some code for, let's say, certification, I think we can somehow, just like Win said, just copy that piece of code in the first place. Yeah, unless kubeadm because can resolve some problem that is tough for us for now, or we haven't have a real solution like upgrade, like all the version management. Does kubeadm support that with very good workflow?
KCP does that for you. The problem that I was actually thinking about though is KCP expects the control plane to become nodes. So I know that that's like not what you folks do. So like the other thing is like kubeadm does a stacked control plane. So like it would run API server controller manager and the etcd pod in one node. And it expects to exec into that node and actually find those pods as well. I don't know how we would want to support that. Truthfully, like it's just it just uses a client to get those pods. And I believe like those pods are named in a certain way. So we could probably use that convention to name those pods in a certain way in the management class. So it would just connect to itself. But it seems like a hack. So we need to test this out. That's the TLDR, I guess.
Yeah. Yeah. So the benefits that I see are like the already drawn out story for upgrades and lifecycle management, all the certificate management that you already do, we pretty much copied it over, which is fine. I mean, we in essence just re-implemented and used a lot of those same packages. The one thing that it doesn't do that we still have to figure out within our machine controller is client certificates, which is where we have to do some kind of, I would call it hacky. It's basically like every single control plane, every individual component of the control plane shares the same certs for all of them. So if you have 5 replicas of the controller manager or 5 replicas of the API server, it uses the same client certs for all 5 of them. There's no specific identities between those that we can deal with. So we still have that problem within this world because we're all pods, and we can't just automatically run those imperative commands to generate those certs based on the CAs. The other benefits, I mean, like what Vince is calling out there, I think is really nice that we could bring over is it's doing that to do health checks, correct? So like it's health checking against etcd. So if something goes wrong in etcd, it'll go and try and help reconcile itself back to the proper state that it should be within the cluster. And so in our world, if something went wrong with our API servers or etcd, we could in essence have KCP help to re-kick those and make sure that they're in a proper state for any of the nested control planes.
So maybe the etcd using the physical storage, I mean, or just like us using memory storage in the first place. Because I think in KPM, most likely you will switch the etcd controller to your own implementation to use the physical storage, right?
Yeah. In theirs, they're going to be using the physical disk to actually do it, which we eventually need to be able to support. I think for right now, like our implementations are okay because we're only doing this or we're still in development, but eventually I think we need to be supporting that as well. Like expecting that you have some PV provider or some CSI provider within your cluster that you could actually use to do.
That's easier for KCP because they assume you already have a node. So you probably have, just temp directory for everything that you want. But for us, that is not an assumption. So you can assume you don't have a node.
Yeah. Now, one of the hacky ways, and this is what Charles and I were talking about as well, is like we could, in theory, because we control both sides of this, and it doesn't like we can translate a node into a workload cluster, into the nested cluster relatively easily. Like those are just it's hacky. So I don't want to call it out as like, this is the perfect way of doing it, but it would be hacky, but we could easily do a bind mount and create like shadow pods or static pods within our nested control planes that map to the same pods within the actual supercluster. So we could go and say, register the pods with whatever names KubeADM actually needs them to be. Yeah, we could do that. And then we could do within, at least in the nested control plane, because nothing's going to reconcile those out of it if we don't want them to. And then we could also make it so that when we fully integrate virtual cluster into this, we can make some label or something on those pods that like doesn't sync them down to doesn't try to sync them down back to the supercluster. So it's not reduplicating that effort. And we could also do syncing of the node object to that to represent the same exact naming of those. And because of VN agent, you'd still have the exec flow as long as those mapped somehow in the actual connections. We could map it so that we could do the exec to an etcd pod that was in the supercluster, but in your tenant control plane, you can't actually do anything against that. You could see it and you could exec to it, but you couldn't actually mutate it, for example. I believe. I mean, correct me if I'm wrong. It's hacky and it might work, and it would create like a full control plane like experience, like more like a full like an actual cluster.
So Chris, are you talking about a multi-cluster solution, or you are still talking about the current enhancement for the multi-tenancy?
This is more just on the actual the nested side of things. It doesn't actually have anything to do with multi-cluster as of right now, although could in the long run. from the side of like, you could run these control planes across, or you could do the same sort of thing that Faye's already working on from the experimental scheduler side of things and still leverage these things. It's just your control plane host would show up in your meta cluster in that world. But this is really just how to bring up nested control planes and more align with CAPI.
So you're saying that now in the VC you can see your own control plane pods.
Mm-hmm. And you could log them, for example, because that would be a part of yeah.
Let's think about it.
Yeah, there's a lot of things that brings in that are different from how it's currently implemented. It would just mean that in like the cube system namespace, you'd have some pods that aren't actually deployed in your cluster. And I think in theory, we could even do this where we created the cube system namespace prior to control plane getting brought up, deploy those into the cube system namespace based on your tenant prefix, your like namespace prefixes. So like those pods could fully show up and to be deployed into what would be gated as your cluster based on the amount of namespaces or based on that namespace prefixing. But we just have some controls that say you can't mutate these objects that got back populated up into your cluster.
So can people delete rows?
It'd be the same thing as static pods where you can't actually delete a static pod. Like you can delete the object, but it just pops back into your cluster and it doesn't do anything.
Yeah, I know for static pod, it will do this way, but in our implementation, I mean,
we would want it the same.
We would do the same. So we put that as static in a node.
Well, it wouldn't actually be a static pod. It would act like a static pod. It's all very like smoke and mirrors in here.
The machine, the nested machine.
I'm thinking the nested machine.
So when we delete we're expected, we should be able to delete the nested machine and the pod should be deleted. The reason for that is because we do have health checks. You could also hook up remediation. So that if something goes wrong, we actually go delete that specific machine / pod in this case that's like creating problem and trying to create a new one.
Oh.
But you could add your own finalizer. So if you need to clean up something.
Cleaning up of machines, we'd probably basically, we'd have to figure out if we'd actually want to leverage that, because cleaning up machines would because we wouldn't actually have a machine in the real world. We wouldn't have a machine mapped to a physical node, and the physical node wouldn't actually be able to be deleted where it would actually do anything. We would just have to build those controls that say, okay, if you delete this, go delete the pods that were supposed to be on that. I mean, I guess that could work.
Yeah, you need to link them all together somehow.
Does it expect that, like, if you do delete a machine, it knows about the pods that are supposed to be on there, and it will expect that those specific pods got deleted? It wouldn't be that we could just delete one set of the pods, not really caring which ones they are.
No, because the names all have to match with the provider ID and all those fancy things. Like there's a naming convention that needs to be followed. So it expects those pods to have certain names. And then it also does the linking between that machine / Kubernetes node and the etcd member. Because, for example, sometimes it can happen that the etcd member is unhealthy and the the controller manager isn't, because it connects with another etcd, or vice versa. So when we detect that, we make sure that we still have quorum before doing any operations. And then remediation kicks in, we delete the machine, the whole chain of pods gets deleted, and then we create a new one. Or you can set it up to create a new one first and then delete the old one, which is the default, I believe.
Okay, that's interesting. So we would, in essence, basically we really wouldn't be able to leverage deployments or stateful sets if we did this. We'd have to be deploying static pods themselves, but we would set up the naming properly to map to machines, because the naming that would come out of deployments wouldn't actually work, or stateful sets wouldn't actually work.
I think so. Yeah, you have to manage pods directly, which isn't fun.
Yeah, so we'd be re-implementing like deployment controllers in essence to do this.
You don't have to, because a lot of that stuff is already implemented in KCP.
Oh, right. Okay, so we would just need to make sure that if you change something that had that naming scheme, API server 1 is on host 1 and controller manager 1 is on that same host, and we just need to make sure that that stack gets torn down.
Mm-hmm.
Interesting. Okay, so there's some interesting caveats there that we'd have to figure out if I think like the lifecycle benefits that we get out of it are really interesting to me. I think what I'm still looking at, like the fact that all of that's already implemented and that we wouldn't have to, because right now we don't have any story for if you tear down an etcd pod or something like that making sure that there's quorum in place or any of those protections. Like those are really interesting in my opinion. But the machine controller would have to be pretty fancy in essence to be able to go implement these things.
Yeah, my worry is because that our assumptions are completely different, right? It's pod based, another is node machine based. Yeah, I'm just I don't know what's ending. If you ending have what is the user experience? So I still. Yeah, listen, but this is again, it's a sort of for cloud-based is different, right? If you change provider, so nothing. It's just for default. Yeah, we still need to figure out all the potential problem if you expose the pods. So.
Yeah, how do normal CAPI users actually reason about the access to control plane pods and like having static pods within your cluster? Does that do folks?
That doesn't happen in like your EKS kind of thing, right?
Right. Yeah, an EKS or GKE, I don't think you even, well, I'm not actually sure if GKE can, but like, I know definitely EKS doesn't show hosts. Doesn't show any of the control plane.
Yeah, it's pod based. Right? If you log in, you don't see any pod. You just have a.
Right.
Okay.
You wouldn't use KCP for that.
Now, yeah, that's why they have they have their own etcd, or EKS control plane provider.
Mm-hmm.
What about like the AWS provider, not the EKS provider specifically, or any of the others that are just physically on host, or even the vSphere? Users of that, do they see any concerns about having the control plane pods showing up in the cluster? Or is that just like, you can't really operate on them, you can't change the API server flags, you can't do much to them other than execing into health check? I guess execing in would provide a lot more controls than we might want.
Yeah, something I can think of is, for example, for that part, you still can read all the configuration, like how many resources you give to that part, right? For like request reservation. I don't know from some cloud provider perspective, should that they may want to hide that information, so they don't want to fully expose how many resources I give to your control plane. I'm just one of, right? I think people, I don't know. So if I'm a cloud provider, I would like to hide it. So I don't want to tell people how many resources I used for this, especially if they have certain kind of charging model. You know what I'm saying? If you're charging money for the control plane, right? But if I show you all the configuration, all the resources I use, maybe that's not a very good idea. But for our upstream, we're probably okay.
Yeah, we can also just not sync what the resources look like, because we control the pods. We'll just make completely fake pods. We'll make it look like they use so much memory and CPU. We'll just charge up the wazoo for whatever customers using your control plane. You can do whatever you want, just fake the entire look so that you can, make more money off of people. Just kidding. Okay. Now, Vince specifically, like, do people see problems with this, or from a platform side of things, when people are building on any of these providers, they're kind of like, it's awesome that you can see the actual control plane components. Like, it ends up being like a kind cluster where you see everything that's deployed that is necessary for the cluster to run within the cluster, which I think is cool from an observability side of things. Like, I can investigate what's going on. I can investigate what my control planes look like. But has that ever been a concern that folks have had?
No, not really. Especially because like you could, with ORBAC, like you could just like not give anybody permission to to do anything on Cube system, right? For that matter. And if someone has the ability to do so, like you have admin permissions and you go and muck with any of those resources, I mean, we cannot stop that. Like, but if you do have permissions and right, like we can't stop that. But at the same time, like exposing the control in the like truthfully that control is it's in cluster API, it's not on the user side. While you can change things out of band, like they can either get reconciliated or they will be overwritten the next time like a rollout happens.
Oh, I didn't even consider that. So yeah, so if somebody were to have RBAC permissions and did exec into the API server and somehow changed API server flags, in theory, that thing is going to get re-reconciled again to be back at the right state based on whatever cap you provided. So you don't. So, I mean, if something goes wrong, at least.
So Chris,
right?
We also need to create a fake vnode object in VC, right? That fake vnode object will be the node for all the control plane parts.
Yeah, one or many. But yeah, we'd have to create some sort of fake, virtual node that we deal with that would represent that same exact naming scheme as well.
We need to have a controller like what you said, a machine controller, to make sure that they are persist, so they cannot be deleted. So.
Yep. And then we need to make sure that virtual node object is also doing all of the binds to make sure that the right pods show up on that host. And then as long as the kubelet endpoint within there is set properly, we'd at least still be able to do logs and exec and all that stuff. Like, I mean, it's relative. I don't want to say it's relatively easy, but it's not that many barriers potentially to be able to implement something like this.
How that will work? So if that is a fake node, how can you proxy the? Yeah, how do you handle the kubelet? Because kubelet has to go to the real node, right? The kubelet request.
Yeah, I mean, you could technically do it the way that we're doing it with a deployment for the virtual node, which would work well. You basically just load balance all of the control plane host through a specific virtual VN agent that goes.
Oh, okay. So that vnode still point to the IP of the right node for that part.
Mm-hmm. Yeah, definitely. Although there's some subtle things in there. Go ahead, Wei.
Yeah, vnode is a kind of a kubelet in terms of a API server. You can implement this way. I think we did some optimization to make sure the vnode is connecting multiple kubelets, but the original design was to one VN agent to one kubelet, and
if you basically did it so that the control plane hosts were only through a single endpoint, it would be easy to do the traffic management of where to send it to the right. Actually, no, it would just behind the scenes, it would just go through the API server, the actual superclusters API server, to do those exec and logs. So even if the in cluster, all the rest of the in cluster nodes were done with the standard one-to-one kubelet to vnode setup, we could have the control plane nodes not done that way, so that we could genericize the implementation, so that even if you went through say for instance, you had three control plane nodes, the faked control plane nodes, those would all have the same kubelet endpoint, and the kubelet endpoint would point to a deployment or a service that would load balance to whatever it needed to go through or route through the Kube API server. And then everything else could go through the normal one-to-one mapping if we wanted to.
Yeah, that's actually bring a kind of interesting thing that if you do that way, if you expose the control plane path in the VC, which means the tenant can somehow auditing everything happens. So which doesn't exist for now. So for now, it's like, more like kind of service kind of thing. So all the maintenance work we are leveraged to the provider, because provider only give you an interface for operating the API server. But in this way, it's like I'm kind of exposed more. If you want to audit yourself, you can do that. That's probably a kind of new behavior.
Yeah, which is interesting. I mean, from our side of things, since we're trying to do a little bit more like, how would you give customers clusters to to do this, those more controls could be both nice and also terrifying from an implementation perspective. Like, okay, you could potentially do some damage now to this if you got access to those control plane pods. I think that's where we need to really make sure that we figure out how to set up those protections.
That's my worry, because
but then again, what Vince was saying. Oh, go ahead. Faye.
If you expect more, you have more flexibility, but again, you are exposing too many interfaces. People are more easily get something wrong.
Yeah. I think it would be very interesting to have a nice and easy way. And this is something that we haven't actually added to like the feature list, but like it would implement a nice and easy way for a cluster admin of one of these nested clusters, depending on how you operate it within your company or for whatever you're using it for. It would give nice controls for that tenant to be able to then log the API server and be like, oh, something's actually going wrong with my cluster. And they have now more controls to debug what's going on versus, centralizing that to like a management cluster, but also the terrifying aspects of, okay, now you can actually see what's going on behind the covers and we can't hide as much from you. I wonder if there's like, I guess these two designs technically aren't, they don't have to be independent. They don't have to be, we don't have to pick one single route for this because it sounds like that could be implemented as an additional piece that says, okay, you can have a nested cluster that's more like a traditional cloud provider's solution. You can't see anything. It's completely hidden. You have to manage it as the management cluster, and you don't ever show any of this stuff. You just give people a Kubernetes endpoint and they go do whatever they want. Then there's the other side, which is, okay, we can also add on top of this and say, okay, if we went down the path of KCP, we could have control planes in the cluster. And those are just like AWS has the AWS provider and AWS has the EKS provider. You get both routes.
Yes.
Yeah, I just have a question. So it sounds like the problem is the pod will be exposed to the end user, right? To the nested cluster end user. So is that possible? Because the pod is going to be created on a supercluster. So is that possible? We just not synchronize this static pod back to the tenant cluster, and then the user will not be able to see all these pods, right? And I think the Kubernetes control plane controller does not need to access the tenant master. It only need to talk to the infrastructure, right? The infrastructure CRD or something, or machine CRD. Is that correct?
I think that's not correct. Vince, just correct me if I'm wrong there. The KCP needs to have a machine mapped to a node within the tenant control plane. And so it has to have a physical node that shows up in the tenant control plane, which means, and the pod has to show up in there. So even if from the management cluster side of things, you could see the pod and you could exec and do all of the health checking against that, that wouldn't actually suffice for, like, KCP would just try to bounce the control plane multiple times because it couldn't exec through its own tenant API server. Correct?
That's expectations that KCP has today because it was built around Kubernetes.
Now, the external, so specifically with etcd, at least, there is a project that is like to allow for externalizing etcd, which would remove those health checks, I'm assuming, or maybe it implements them in a different way.
Yeah, it will implement them in a different way, but that doesn't change the fact that it won't do the health checks for API Server Controller Manager and the other pods on those machines, and the node itself as well.
Interesting. So that might be something as well that we could leverage, if, like, because etcd might be a little bit more scary to show in a control plane. Like, I might be more okay. I mean, I'm making a bunch of assumptions here, but it might be more secure to be able to show what the API server and controller manager are doing, but hide etcd if we wanted to, and treat that as external, even though it's just deployed as a pod in the control plane, and still do health checks against the API server, which is a potential path as well.
The other thing is, like, we do connect to etcd, so we exec in the static pod, and we port route proxy back the port from the etcd pod back to the management cluster, so that we can say remove this member from etcd, or like check the health of the etcd cluster. So we need to be able to connect to that, which might be a problem if you just sync up the pod.
Yeah. Okay. So maybe we wouldn't want to be doing that.
Yeah.
Well,
I
syncing up the
believe
pod,
that-
we'd still be able to have it because it would still get registered with the tenant control. Well, anyways, I'll let you go ahead.
Right, but then if I do exactly in the pod, like what happens? Right.
Yeah. Yeah. I mean,
Yeah.
we have to route those. We have to handle all of those things and make sure that it goes to the right place still.
I was trying to think of alternatives, but was wondering if like we could create like a client that's connect to a cluster, but that cluster is just a bunch of resources that then, so like another shim, I guess, like, but then you will need to route those requests through the right pods. Yeah.
And realistically, nothing goes through a node directly, correct? Everything goes through the API server to make connections. So like if it's going to do a health check against etcd, it's going to go through the API server to etcd that's as a static pod. So what we really need to make sure is the connection there is that the API server registers the pods that we want to be able to connect to, and everything else should be relatively fine. Because you're not doing, because like nodes don't actually matter as much as the getting to the pod based on some specific naming sequence or scheme, as long as you can get through the API server, the workload clusters API server.
Yeah, I don't know. I was thinking like maybe there is a way to create a fake node in the management and then just run kubeadm on it, but that also doesn't solve the problem because like you have this, your network is split, right? Because like you have the worker nodes on somewhere else, which complicates a little bit.
I think this is still doable. I mean, like if we're okay with some of the caveats there about pods showing up in control planes, I think this is relatively doable with a couple custom syncers. And we could write a out of VC custom syncer that you deploy specifically for this. So that if folks didn't want to actually do it, we could just, sorry, I'm removing somebody. If we didn't want them to actually, like if you didn't want to deploy this, you could deploy it separately and not use this specific syncer. Because just like you have, Faye, you wrote the custom syncer, and internally we have our own custom syncer so that we can support CRDs and things like that. We could easily do that kind of function and not override anything that's in virtual cluster, not force any changes there, except for somehow supporting some flag to allow us to backport specific resources. Okay. Interesting.
Yeah, we'll need to think about it, and maybe this is it's kind of a lot to right now to take a KCP and make it like non-kubeadm aware, because like it will have those expectations and the code is really tied up together. Although truthfully, like if we think about it, like it would be really, really great if the API of a control plane provider were actually separate, and then you would just implement those bits. But that's like a whole thing that needs to happen.
Is that something that's actually planned or been talked about within?
No, I just thought about it right now.
Okay.
Yeah. But yeah, I don't know. It's also like super complicated code. So
yeah. All right. This is gonna require some more work, and we should definitely confer over Slack on this, because we're almost at the end of the hour. So I want to make sure and give folks at least 5 minutes back. We didn't get to milestone planning. Can we do that over Slack? Do you all agree that we can just basically do some filing of issues? I'm thinking the things, sorry to derail this conversation for just a second. We can go back to it as well, but we can do things like filing some issues for how to integrate CapN and VC. I'll get an issue filed for doing an actual release. Vince, I'm probably going to poke you about that just to make sure that I have all the right things. The big open questions I have there are like, do Do I need to create a project within Google Cloud? How do I get access to those kinds of things? How does Proud push those? I've never done any of those things. So I'll probably poke you pretty soon about that. But yeah, I'm thinking if we can file some issues and then start triaging those. So how to get virtual cluster actually integrated. So meaning we probably need to have a way to supply out of a non-virtual cluster provided kube config to virtual cluster. Like we probably want to add to the virtual cluster CR an actual kube config field or something like that. I don't know, Faye, if you've thought about how we can integrate these two pieces together without having to break virtual cluster.
That's okay, because it's kind of provider now. We already have two providers now. We have a cloud provider, we have native provider. So we just need to switch the cloud provider to a new version. Switch whatever you have, because whatever we need to have is the kube config. You want to get a kube config somewhere. If you don't want to change the spec, you can just, like always, hacky way, tricky way, you put kube config in the annotation somewhere. So no, and that's something that we did actually internally to work on some problem. So especially
Cool. All right. So yeah. So if we can just do that over Slack throughout the rest of the day or something like that, I think that'd be awesome to get some of those things filed, and then we can plan out what the 1.x actual release is going to be, and then I can work through getting the main branch up and work through getting the Proud job so we can get our first initial release created. Then we can start moving this thing forward a little bit more. Does that seem reasonable? Cool.
Yeah. I think for KSP stuff, I think it's pretty interesting. We haven't thought through more about this, so I see the benefit and I see the kind of drawback. So maybe someone, if they feel it's very interesting, and if it doesn't really take too much work, you can try to do some POC and give a try. I mean, Thinker, I don't worry about a Thinker. I think Thinker is the less problem than that. So the major problem is first workflow and what kind of problem we solve, and what is the user experience impact.
Yeah. Charles, I know you had some interest in this. You and I can continue talking as well if you wanted to run with that as well.
Right. Yeah. Mm-hmm.
Cool. All right. I'm going to call it then and give everybody a little bit of time back, and we'll chat over Slack for the rest of the day.
Okay.
Great.
Bye-bye.
Thank you, everybody. It was fantastic, as always.